In 1931, engineers faced an impossible truth beneath the Nevada sun. If they built Hoover Dam the way every dam had ever been built, 3.25 million cubic yards of concrete would generate so much heat it would take 125 years to cool, cracking the entire structure apart before it ever held back a drop of the Colorado River. No blueprint on Earth could prevent disaster. But as political pressure and economic collapse demanded a miracle, one man's untested idea would threaten the whole project and rewrite engineering history. Why did the greatest minds in America nearly fail? And what gamble solved the problem no engineer could crack? The numbers defied belief. Hoover Dam demanded 3.25 million cubic yards of concrete, enough to pave a highway from San Francisco to New York. But inside every cubic yard, a chemical reaction unleashed a hidden danger. As cement and water mixed, heat surged through the mass. In smaller projects, that warmth faded in days. Here, the heat would build and build, trapped deep inside 50-foot thick walls. Calculations from Bureau of Reclamation engineers warned that left alone, the concrete's core would stay hot for more than a century. Not just warm, over 140 degrees Fahrenheit at the heart, while the surface cooled and shrank. The difference would tear the dam apart from the inside out. Cracks would snake through the structure, each one a fault line threatening collapse. The best estimates said 125 years before the concrete could naturally cool and cure. By then, the dam would have failed, its promise lost in the desert. No dam on Earth had ever faced this kind of thermal siege. The problem wasn't just scale, it was time. Every day the concrete stayed hot, the risk of disaster grew. The world's largest concrete pour had become an engineering trap with no escape in sight. For decades, dam builders followed a simple rule: pour concrete in layers no taller than 5 feet, then wait. Each section, called a lift, would sit exposed to the air for weeks or even months, letting heat bleed away before the next layer was added. On the biggest projects, this meant years of patient work, sometimes stretching into decades. Cracks were expected, even tolerated, as long as they didn't threaten the whole structure. Time was the only cure. But Hoover Dam faced a deadline no engineer could ignore. Congress gave just 7 years for completion, an order written into the contract, with millions of dollars and national pride on the line. There was no room for the slow, cautious pace of tradition. The old method would have forced crews to halt after every pour, letting the concrete rest while the desert sun beat down. With 3.25 million cubic yards to place, even the most optimistic schedule would have stretched past a generation. The pressure was relentless. Every day lost to cooling meant another day the river ran wild. Another day the country waited for power and water. The familiar rhythm of pour and pause, once the bedrock of dam building, had become a trap. Something new had to be tried, or the whole project would grind to a halt. Frank Crowe was known for moving fast. He had no patience for waiting a century. His answer to the concrete crisis was as radical as it was risky. Instead of letting the dam cool on its own, Crowe ordered more than 582 miles of steel pipe to be woven through the heart of the structure. Each pipe, just an inch wide, would carry water colder than the Colorado River itself. At the base of the canyon, crews built a refrigeration plant that could freeze 1,000 tons of ice every day. The coldest water, chilled to 35 degrees Fahrenheit, was pumped through the pipes, block by block, pulling heat out from deep inside the concrete. Every new pour became a race against the clock. Sensors tracked the temperature inside each 5-foot lift. If the readings ran too hot, more chilled water flowed. If they dropped too fast, pipes could burst or the concrete could crack. Crowe's team managed each block as its own experiment, cooling and curing them before the next was poured. Once a block reached the right temperature, the pipes were cut, flushed, and sealed forever in the dam's core. The entire system was a gamble, untested, unproven, and essential. But for Crowe, it was the only way to build a dam that could survive its own making. The Great Depression left a quarter of the country without work. In Washington, politicians gambled $49 million on a single project, enough to build a dam and, with it, a symbol of hope. The plan carried Herbert Hoover's name, even as critics argued over whether his legacy deserved it. Out in the Nevada desert, there was nothing but rock and sand. To build the dam, workers needed food, water, and shelter, so Boulder City rose from scratch, a government town for more than 5,000 people. Streets were laid out in a grid, houses built for families, and rules posted on every corner. Drinking was banned, gambling forbidden, and the company police enforced a strict code. Men who broke the rules could be evicted with a day's notice. For most, the alternative was hunger. The town promised steady pay, but life was tightly controlled. Every train that arrived brought more men desperate for work, some with families in tow, hoping to trade hardship for a weekly wage. Boulder City became a world unto itself, orderly, efficient, and always under watch. The pressure to finish the dam was everywhere, from Congress to the desert streets. Every delay threatened not just a project, but the fragile morale of a nation looking for something to believe in. Day after day, men lined up at the edge of Black Canyon, faces burned by the desert wind, shirts soaked through with sweat. The sun hammered the site, pushing the air to 120 degrees by noon. In the tunnels, it was worse. Exhaust from diesel drills and blasting powder thickened the air, turning every breath into a struggle. Some workers collapsed where they stood, overcome by heat stroke before the lunch whistle. Others never walked out at all. Official records count 96 dead, but the true toll runs deeper. Hospital logs filled with cases of heat exhaustion, pneumonia, and men poisoned by carbon monoxide. The tunnels, meant to tame the river, became traps. Ventilation was poor, and the deeper crews went, the thicker the fumes. Powdermen, those who set the charges, were hit hardest. Their lungs burned, skin slick with sweat, eyes stinging from dust and gas. Families in Boulder City waited for news, sometimes for days, when a man failed to return. There was no safety net, only the promise of a wage. In the rush to meet deadlines, risk became routine. The human cost of speed was written in silence. Names lost to time, remembered only in the dam's shadow. Spring 1933 brought the Colorado River's fury straight to Black Canyon. Melting snow in the Rockies sent a surge downstream, with water rising by the hour. 4 diversion tunnels, each blasted through solid canyon wall, each wide enough to swallow a locomotive, were the only things standing between the flood and disaster. At the peak, 85,000 cubic feet of water crashed through every second. The upstream cofferdam, built from 500,000 cubic yards of earth and rock, began to tremble. Crews scrambled through the night, stacking sandbags, shoring up weak spots with whatever they could find. For a few hours, the line between triumph and catastrophe narrowed to a muddy ridge. But by dawn, the cofferdam held. The tunnels did their job. Foundation work resumed in days, not months. By 1935, the final test arrived. Engineers began to fill the reservoir even as the last blocks cured. Thermocouples buried deep in the concrete sent back numbers, temperatures dropping, stress lines holding. The cooling system had worked. The dam did not crack. Word spread quickly. Within a decade, engineers from Europe, Asia, and South America arrived to study the cooling pipes, the block-by-block construction, the lessons learned at Hoover. Today, the same principles guide the building of nuclear plants, skyscrapers, and bridges around the world. The river was tamed, but the real legacy lay in the blueprint it left behind. When the last of 3.25 million cubic yards of concrete was poured into Hoover Dam, engineers knew their greatest risk was hidden inside: heat that could have cracked the structure apart for over a century. Crowe's unprecedented cooling system, 582 miles of embedded pipes, cut curing time from 125 years to just 2. Official records show 96 workers lost their lives, and thousands faced deadly heat and toxic fumes to meet a deadline set by national crisis. Today, Crowe's method is used in skyscrapers, nuclear plants, and infrastructure worldwide. Yet some internal engineering debates and early temperature readings remain unarchived or only partially published. Hoover Dam stands not just as a monument to overcoming the unsolved problem of thermal cracking, but as proof that engineering breakthroughs often emerge under the pressure of real-world necessity. Its legacy can be measured in concrete, in lives, and in every structure that followed.